Hi, welcome back to another Math 112 lecture. We're going to continue our conversation about conic sections by talking about ellipses today. Now, ellipse is a mathematical way of saying oval. So don't let it confuse you too much. Ellipse just means oval. But there is a very specific mathematical definition for an ellipse. And remember, with a circle, we defined the circle as the sum of all points whose distance from a given point was equal to a specified value. Ellipses are defined based on the distance from two specific points, which we call foci. Foci is the fancy way of saying multiple focus points. So foci is the plural of focus. And what we do is, for any point, if the sum of the distances, so if we've got a point xy, and this point is some distance d1 from focus point 1, and some distance d2 from focus point 2, we add those two distances together and we get some specific distance d. All of the points whose sum of the distances from the two focus points is equal to d, if we graph that set of points, we will get an ellipse. One way of thinking of this is thinking of a string that is a little slack between two nails. If we put a pin in that string and we start dragging it so that the string stays taut all the way around, we will scribe an ellipse. All right, so because we're talking now about foci and we've got kind of a squash circle, we've got a few more pieces of information that we need to be able to talk about. Our major axis, this is the axis on which the foci lie. This is also the longest axis of the ellipse. So your ellipse will always be on your longest axis, called the major axis. The axis that is perpendicular to that axis and goes through the center point of the ellipse is called the minor axis. Now, the center point of the ellipse is going to be halfway between the foci on the major axis. And then we talk about vertices at either end of the major axis. The standard form for the equation of an ellipse is x minus h squared divided by a squared plus y minus k squared divided by b squared is equal to 1. Now, the key here is, so I want you to compare this to, if I write the equation for a circle, x minus h squared plus y minus k squared equals r squared. And then if I divide that through by r squared, I get a very similar equation to the equation for an ellipse. Here is the difference. If a squared and b squared are not equal, you are looking at an ellipse. If your coefficients on your x squared and your y squared are equal, you're looking at a circle. So this is the standard form for an ellipse. The center of the ellipse is going to be at coordinates hk. Now, this is the standard form for either a horizontal ellipse or a vertical ellipse. The only difference is whether your foci are stacked one on top of the other or next to one another. For a horizontal ellipse, your horizontal vertices will be a units to the left and right of the center. If you have a vertical, actually, there will be points on the ellipse that are b units above and below the center. And if you have a horizontal ellipse, so if A is bigger than B, then there's this parameter C that is equal to the square root of A squared minus B squared. That gives us the distance from the center to the focus point on either side. All right. So let's take a look at this. We're going to graph the ellipse, and I know it's an ellipse because both x squared and both x and y are squared, and they have positive but differing coefficients. So I'm going to graph the ellipse that is described by the equation x plus 1 squared divided by 9, which I'm going to write as 3 squared, plus y minus 2 squared divided by 5, or 25, which I'm going to write as 5 squared, plus equals, 1. I did that because I want to compare that to my standard form, which is x minus h squared divided by a squared, plus y minus k squared divided by b squared equals 1. So I know h is -1, b is 2. So my center is at the point -1, 2. I know a is 3, b is 5. So from this I know that b is greater than a. So I have a vertical ellipse. So my major axis, major, it's M-A-J-O-R, is a vertical axis lying along the line x equals -1. My minor axis is a horizontal line that goes through the center, so that's going to be at y equals 2. My vertices, well, let's talk about the endpoint. Let's talk about my vertices. So my vertices are on the major axis, and they are b units above and below the center. So I have a vertex at -1, 7, and a vertex at -1, -3. My endpoints of my minor axis are going to be a units to the left and right of my center at 2, 2, and -4, 2. Now to find my foci, I need to find C, which is going to be the square root of b squared minus a squared, so 25 minus 9. That's the square root of 16, which is 4, which means my foci are 4 units above and below my center at the points -1, 6, and -1, -2. Let's see if I'm right. Let's take a look at the graph. All right, I've got my center at -1, 2. I've got, this is my oval. I just had Desmos graph this for me. I put in my endpoints of my minor axis at -4,2 and 2,2. My major axis is indeed vertical. It's the longer one, and I have vertices at -1, -3, and -1,7. And you can see my major and minor axes. Okay, looks like we did pretty good. All right, let's try another one. So I want to write the equation of an ellipse with foci 2, 1, and 4, 1. So I have just graphed those. So my foci are at point 2, 1, and 4, 1. And I have a vertex at 0, 1. Now, if I have a vertex at 0, 1, so let's talk about this. We know some stuff already. We know where our foci are. So we know our center. The center is halfway between the foci. So the center is going to be on the same y line. So it's going to have the same y coordinate as the foci. But its x coordinate is going to be halfway between 2 and 4, which means 3. Okay? Now, one vertex, I have a vertex at 0, 1. That is 3 units to the left of my center. So I know now that A equals 3. And so there will be another vertex at 6, 1. Right here. And here's my center point. Okay? Now, I also know that my foci are only 1 unit away from my center point. So that means that C equals 1. And since C equals, and we can see because my vertices and my foci are all on a horizontal line, we can see that this is a horizontal ellipse. So this is going to be, C is going to equal the square root of A squared minus B squared. So 1 equals the square root of 9 minus B squared. So 1 equals 9 minus B squared. And sorry, that's not 9. That's 3 squared. Oh yeah, that's right. So B squared equals 8. So now we've got everything we need to write the equation. We've got the center. So this gives me H and K. I've got A and I've got B squared actually. So my equation is going to be X minus H, which is 3 squared, divided by A squared is 3, so A squared is 9, plus Y minus K, which is 1, squared, divided by B squared, which is 8, and that always equals 1. Okay. That is the result. And I think I have the graph right here. I do. This is actually the graph of the ellipse that we have described. Okay, you can see my other vertex is right here at the point 6,1. My center would be right there. One focus, two focus, and the other vertex. So just as with parabolas and circles, we need to be able to convert from expanded form, something like x squared plus 4y squared minus 2x plus 24y plus 33 equals 0, into standard form. Now, we can recognize that this is an ellipse because both x and y are squared. They have coefficients of the same sign. So they can be either both positive or both negative, but they have to be the same sign and a differing numerical value. So we recognize this as an ellipse. So in order to convert this, what we're going to do is group the squared variables together, just like we did if we had a circle. So we're going to group my x's, any term that contains an x raised to any power, and any term that contains a y raised to any power on one side of the equation, and my constant on the other side of the equation. Now we're going to complete the square. So when we complete the square on this, we put parentheses around my x's and we leave a blank. I'm going to take 2 divided by 2, so take half of the middle term, which will be in this case 1, and square it, so I'm going to add 1. I have nothing in front of my parentheses, so I have only added 1, so I add 1 on that side. Now for the y's, I take half of my middle term, so 6 divided by 2 is 3, square it, and we get 9. But what I've actually added is 4 times 9, or 36. Okay. Combine like terms, and we end up with x minus 1 squared plus 4 times y plus 3 squared equals 4. The last thing we do is we divide through by 4 so that the whole thing equals 1. And we get standard form. Now this is the standard form for a vertical ellipse that is centered. I know it's vertical, no, sorry, horizontal ellipse that is centered at 1, -3. A is 2, B is 1. We can go from there to figure out the rest of it. And actually it's right here. So this particular ellipse will be centered at 1, -3. A is 2, B is 1. So the vertices are 2 units to the left and right of the center at that is incorrect. Vertices are 2 units to the left and right of center, not there, but at -1, 3, and 3, 3. We will have points on the vertex 1 unit above and below the center at 1, -4. And 1, -2. The foci are 1 minus the square root of 3. Well, they're square root of 3 units to the left and right of the center. So that's going to be 1 minus the square root of 3, comma -3. Yeah, that's -3. And 1 plus square root of 3, comma -3. Major axis lies along the line y equals 3. Minor axis lies along the line x equals 1. All right, so ellipses are not too awful hard. They're not very scary. They're not very complicated. They're pretty well behaved. Just pay attention to the standard form, and you do need to know how to complete the square. If you're having difficulties, please be sure and get a hold of me sooner rather than later. I will see you all soon. Have a great day and do good math.